Hi guys, welcome to Learning Electronics Repair. I have two inexpensive multimeters here. This is not a sponsored video or a sponsored review. I actually bought these myself, or more accurately, Detlef bought that one and I bought this one. I bought these because they were mentioned in comments to the other cheapo multimeter review I made. So let's give them a go, I thought. This one is a manual ranging multimeter, UNI-T, a well-known brand, possibly well-respected also. So this costs about €20. This one, ANENG, another very well-known brand and quite likely well-respected in certain quarters also. This is an auto-ranging multimeter and this is a bit less than €10. So this is the cheaper of the two. Let's have a quick look at the specs on paper. Then let's look at these multimeters. We'll have a quick play around with them and let's see if either of them is better than the other for repair work, or if both or neither are really any good. Yeah, I've never used these before. I have no idea how this is going to work out, but no doubt we will find out soon. This is the ANENG M118A multimeter. Display 6000 counts. Capacitance test, yes. Continuity, yes. Non-contact voltage, yes. Zero line fire line test. I'm not exactly sure what that is, but it does have it. All unit symbols, yes. Backlight, a manual backlight maybe, yeah. True RMS, automatic shutdown. It has a flashlight built in by the looks of it. Diode test. Sampling rate, yes. I'm not quite sure what that's supposed to tell us. Sampling rate, yes. Let's see, ranges. So it has a 6 volt, 60 volt and 600 volt DC range. Nothing low ranging particularly. 600 ohms seems to be the lowest resistance range. 10 nanofarad, 10 millifarad capacitance range. 60 millifarad even. Okay, so very good for large capacitors at least, and maybe some reasonably small ones too. 6 amp AC current, 10 amp DC current. I'm looking at the actual meter now, so it's actually saying ohms down to 0.1 ohms, continuity the same. For some reason now it's 20 nanofarad on the capacitance and not 10. They don't really make their mind up. Diode test up to 3 volts, that means it'll probably test some LEDs or most LEDs, at least the small ones. 20 milliamp range, half a volt range. So look at the picture, this appears to be somewhat different from the specification I was just looking at. A little bit of information on how we use this. It will be interesting to see how intuitive this is to actually use. Lots of long presses and short presses going on. Non-contact testing, as it mentioned. We can tell you which is alive, basically. Firewire and zero line. I think this means like live and neutral, yeah. Firewire is something completely different, I think. IEEE 88 something or other. Flashlight, small. Intelligent auto ranging, yeah. Has a fuse, so it says. And it's drop resistant. This is interesting. It's saying don't do this. So they have it in the 20 amp socket and common. Yeah, this is a different meter altogether as well. And it's saying don't do this. Okay, don't do this. It's explaining how you use an ammeter. Okay, that's fair enough. Actually, that's quite useful. And there we go. The UNI-T, well, this is the manual ranging one. It's the UT33D+. So DC voltage. This looks like it goes down to much lower. 200 millivolt range. AC voltage, it only has a high voltage range on the model I have. DC current, 200 microamp range to 10 amps. AC current it doesn't have. Resistance ranges, looks like it has 200 ohms to 200 mega ohms. This one for my model. It doesn't have capacitance, so there are differences between these two meters. Cat to 600 volts, drop test to 2 meters, auto power off, auto backlight, diode test, continuity. I think we've had enough at looking at that, don't you think so, guys? Let's try these. Which one shall we try first? Or shall we try them both together? No, I think that would be confusing. Let's try one first, but which one? Eeny, meeny, miny, mo, catching that one. Okay, this is the one we're going to try first. Let's see if it has batteries in. No, it doesn't have batteries in. Okay, nothing particularly unusual. Opens up easily enough, and we have 2 AAA batteries. Well, I will say the batteries are very secure in here. They really click into place. That's probably quite handy. They're not likely to come loose. And we're on auto. Let's look at the meter probe as well. So these look very inexpensive. I think that's the best and most kind thing I can say about them. Very inexpensive. Are they a standard size? I think they are a standard size. Common volts. Okay, yeah, these feel really cheap. We will use them, but I'll just try with my meter probes to make sure the standard ones I use do fit. These are the ones I've been using on my videos. Ah, so they do fit, but they kind of like stick out a lot. That's interesting. Let me just try the ones off my other meter. This is my other ANENG meter. Let's see. These fit. Yeah, they do fit, okay. Although you can see that these are like a mismatched pair that I have in here anyway. This meter didn't come boxed, by the way. It came like a plain envelope, like a bubble wrapped envelope thing. And I will use the probes that came with it. And the first thing I always do with a multimeter is see how good the continuity tester is and the diode range tester. And will it give one bleep on a semiconductor junction and a continuous one on a short? Because that's something I really want on the meter. Let's have a look. So, hold that down, that puts the light on. It's quite clear actually. Hold down, turns it off. Range, this says H. H or BL. Oh, it's I bet it's hold. I bet it's hold. Is this the range, I think? Auto DC. AC true RMS. Resistance. Ohms. Diode. Back to nanofarads. Back to auto. Oh, so I think the auto on this is kind of this little thing where it will find if there's a voltage or a resistance automatically. Yeah, that says it's a resistor. I think this will tell you it's a voltage. Yeah, auto volts. Does it work the other way around? I often wonder about this auto volts, if it will work on the negative voltage. Let's try it. Yes, it does, and it's fast actually. That is pretty fast. Okay. Obviously you can't use in this mode for continuity testing, but you wouldn't want to really. Is this continuity? I think that might be supposed to be a bleeper. Guys, that is extremely fast. That's what you want for a continuity tester. Okay. I'll give this good mark so far, I'll say that much. Haha, the big test. What happens? No bleep. Find the diode. No bleeps at all on the diode test mode. That, to me, it's a no for repair work. I'm sorry. Why can't they just do this right? Look. Diode test mode. Yeah, diode test mode. It's not difficult, is it? Look. Bleep. Where? Diode. Blip. Schottky diode. Blip, yeah. Blip. Right. If I put that meter somewhere where you can't see it, yeah, and I test something like a short or a diode, you tell me which one it is. Yeah. Yeah, you guessing? That's why this is how every multimeter should work. Continuity in diode mode. And it can't be difficult. How is this so difficult? Yeah, that's a rant, guys. But any meter that doesn't do that, personally, for me, there's no use. I don't want to be looking at the display to see if it's a short or a diode. I want to be looking at the thing I'm probing, yeah? The only thing that would be better than that would be a different frequency blip on a Schottky diode compared to a normal one. Now that would be something, yeah? So if you could hear normal diode and Schottky diode, and it made a different frequency tone, now we're talking, yeah? Okay, so let's try the meter anyway, but personally, although it looks very good to start, maybe it's only me who wants that facility, nobody else. That's why they don't put it on, because only I want it, yeah. Well, while we're here, let's try a Schottky diode, because the Venlab meter I tested couldn't actually test Schottky diodes. This tests them just fine, minus the bleep, unfortunately. We can't hold something down to get a bleep, can we, out of it? That's the torch. Yeah, that's a torch. That's nothing to do with it. That's the non-contact voltage test. Okay. While we're here, let's try the non-contact voltage. So here's a mains lead. It's plugged in, but not plugged into anything. Yeah, live. EF. Well, actually this says EF regardless of what I pointed at. I'm not sure what I'm supposed to be doing, actually. Oh. Ah. Oh, yes. I like it. How about resistors? Well, we're on auto resistance range at the moment. We'll look at some low value ones. So this is a 0.1 ohm. What's it reading? 0.1 ohm. And he did that on the auto range. That's quite nice. Find something a little bit bigger. This is a 0.3. Yeah, that's reading about 0.8. What's reading on the leads? Well, the leads are reading about 0.3, which surprised me. It could actually read the 0.1. Maybe not extremely accurate on those. Let's go back to this one. Yeah, now it's reading a little bit more. I don't know how it managed to read it before because the leads have a bit of resistance. Let's try the opposite end of the range. Very high value resistance. So this one is a 10 meg. Yeah, it reads 11 meg. I mean, it tells us it's a very high value resistor. Maybe not totally accurate. We'll see what the other meter reads on that one. Let's go back to the auto range and see how well that works with these resistors. So this is auto range. So if I connect a low value resistor, 0.1 ohm, does it work out what it is? Yep, that works very quickly. Try the 0.3 ohm. That also worked very quickly. Will this work on the high value resistor? I'm wondering if it can actually figure this out. Let's see. Oh, it certainly did. That works well. I'll give it that. What's it do with diodes on the auto range? Well, actually, it thinks it's a resistor. Other way, should just think it's open. Yeah. I'll try a Schottky diode. I'm not touching this leg with my finger, by the way. Thinks it's a resistor. So, yeah, the auto range I quite like. It's quite possible this one doesn't do. Diodes on auto range, and I have seen meters that will do. The KAIWEETS one would. I think we should test some capacitors. It's saying it has a 20 nanofarad range to 60 millifarad range. Okay. Here's a 1 nanofarad, so let's start with this one. Yeah, it reads 105. Pretty close that is, to be honest. Go for something smaller. This is a 1 picofarad. This is the smallest you're ever likely to see. Will it read it? I'm not sure it will read this low actually, but we can try. Yeah, it won't read down to 1. See what it will read. These are 12 picofarads. See how this one reads. Yeah, it reads it, but it only reads it as 0.003. Let me have a think about it. So 1, this should read about 1.2. But you can't read 1.2 because you don't have the 0.2. So it is reading them that small. It is telling us there is a capacitor. I'm not sure again how accurate that is. Let's go towards the other end of the scale. This is a 2200 microfarad. See what it thinks of this. So what normally happens with large capacitors on the multimeter, it takes time. Whereas a dedicated capacitance meter will read them immediately. So that's reading, yeah, 2350 rather than 2200. This is the largest one I have here. I think I have a couple of these, 10,000 microfarad, which is basically 10 millifarads, 100 volt. So you think of this. Just puts a pin out of this thing. 1, 2, 3. Okay. Oh, I see. So this one looks like it's the negative. And this looks like it's actually the pin. Well, I don't know if this is a bad capacitor. Oh no, look, I tell you why, it takes a while. But it's going, you know, it's just taking time to read this. Yeah. 85 basically, 8,500. So that's saying like, yeah. So yeah, so that was saying like 8,500, the 10,000, I mean these are poles. So capacitance range, very functional on this one. Quick look at voltage and amps, and then we can look at the next one. You can see my bench power supply there, or one of them at least. You can see the meter. I don't know the accuracy of this display anyway, but they're reading basically the same. That is for sure. Okay. Just turn the voltage up, obviously. This up to 32. Down to 0. Well, that's actually saying 1 volt on there because the finer just is not set up. So that is okay. We'll try current as well. So I've just turned the power supply right down at the moment. I'm just going to see if we can get 10 amps into this. Although in fairness, there will be some resistance in the leads. It may not go to 10, but we can try it. So amps range. Okay, we choose AC amps. The power supply is set to 0 at the moment. Let me just find the right range. That's voltage range. Well, it does say this has an amps range. How do we get to it? So AC amps. I have the leads in the right places. I'm actually going to have to read the user manual now. I can't actually figure this intuitively how to get to that. So guys, we have the answer. Current test. Press the power key for more than 2 seconds to turn the meter on. The boot is shown as automatic scan auto. Okay, so we've done number 1. Now 2. Insert black watch pen into COM jack and red watch pen insert 10 amp jack. Test watch pen reliable contact test point. I think that's that, yeah. So we have input current greater than 20 milliamps between the input COM and 10 amp. The meter will display the current value with large D components on the LCD according to the magnitude of AC/DC component. Before the instrument is connected in series, the power should be switched off. Maximum input current is 10 amps. Don't use it for more than 10 seconds. That's quite normal. And then switch the power supply off. And no more than 36 volts DC or 25 volts AC. Voltage is entered between port 10 and port COM. Huh? So it's saying you can't measure current on high voltages. Well, that's well, what do you think, guys? We'll test it anyway, but there's 2 problems with this. One, apparently it can't test current below 20 milliamps, which is pretty useless really, because usually when I want to measure current, it is below 20 milliamps, especially microamps on a CMOS battery, and it can't test current on voltages over, well, 36 volts DC. Well, my power supply is set to 12, so let's give it a bit of current and let's see what happens. We have current. Oh, it's reading it. I mean, it is reading it. Let's not beat about the bush here. It is reading it. Okay. And then it will sort of cut out, I'm guessing. Oh, actually, it did read a little bit more. Okay. So that's how the current range works on this. Let's give it some. 5 amps is as much as I can get down these test leads. That probably is the test leads. And in fairness, we won't run it for too long. Okay, so the amps range works, guys, but in my opinion, that is not really suitable for a repair test meter. If you do the type of repair I'm doing, depending on other people's usage, it might be perfectly suitable. So, the ANENG M118A. Plus sides, it's cheap. The auto range between resistance and voltage measurements was very fast. Switching very fast between the modes, I did like that. It would do it on very high resistances, very low resistances. The bleeper is just not suitable for what I want to do, and I've shown you why. But so far, I've never yet found an inexpensive meter that can implement such a simple thing, yeah? So, it is quite a handy little meter, this. And we often need more than one multimeter. The thing measuring large capacitors, it certainly measured them, it takes its time, but that's normal. It would test Schottky diodes, normal diodes, that's fine, just the bleep. The non-contact voltage, I really liked it, I thought it worked really well on this meter. Another thing I really did like this is how fast it responds on continuity test. That is definitely usable. If you've got €10 or less, you can do a lot worse than this. I can't think at the moment of anything particularly better than this. There are some features missing I would like, but at that price, I think it's about the best one I've seen so far, at least. Comments below, guys, on that one. €10. Can we get better than this one? If so, tell me, I will buy it. Now let's have a look at the UNI-T. Well, the first thing I will say, this is chunky. Yeah, this is really quite chunky for a multimeter. Maybe that means there's more good stuff in it, I don't know. There it is. We have a little plastic shield on here, if you like. If I can remove it. Yeah, just starting this corner edge, that's the thing to do, yeah. It's a bit awkward to get this one off, actually. I have it. Okay, so that's the meter. First thing I'll say, it has a smaller display than the other one. Again, it has no batteries. This might not apply if you order one. I mean, we live on a little island here, so everything comes over by airmail, and there are restrictions on batteries and airmail, so it's not strange, I think, that we don't have them. Looks like we need to take this plastic cover off to change the battery. Yeah. And there's the battery cover. This also takes 2 AAA batteries, so we'll put some in. This is like a silicone cover. It's very flexible. Obviously, this gives protection if you drop the multimeter. It's also fairly evident this was designed for field use because it has the holders built into the case for the test probes. Like so. The test probes definitely seem to be better constructed than the ones that came with the other meter. These are also the longer type ones, which means that I can fit the ones I use on my Fluke. Something I couldn't do with the other meter. Yeah, those fit perfectly. When I say I couldn't do, I could, but they were just sort of sticking out rather further than you would wish. Okay, so let's go straight to the crux of the matter here. Continuity mode and diode test, okay? Well, they're both in the same position on this. See how fast this is. I'm not quite sure that's as fast as the other one, but it could be the meter probes. Let me try it with my Fluke probes. Okay. It's the meter probes, guys. But to be quite honest, whatever meter I buy, I end up buying my own probes for it anyway, even the fluke. Maybe just rub these over with something just to clean any sort of corrosion or film off them. Works pretty well. So, continuous bleep on resistance. Good. What's it do with the diode? What does this do with the diode? Well, nothing in this range. It's not testing the diode. Do you have to press something? Select. Oh. Oh. Now we have a diode symbol. Yeah, ohms diode. Now it doesn't bleep at all. And it doesn't bleep at all. So it failed. Failed dismally again. This is not what you want for diode test mode. Let's just try a Schottky diode to make sure this can measure them. We did find one meter that couldn't even measure them. Yep, measures them perfectly. So once again, I have failed to find a cheap multimeter that works when it comes to diode mode and continuity. Or at least works as far as I'm concerned, yeah? I suspect some of you guys actually really agree with me. Okay, so ohms range, low ohms. What's it do? Well, this meter thinks this 0.1 ohm resistor is short, whereas the other meter could actually read it. This one can't, so that is one up to the other meter, the ANENG. Even with a 0.3 ohm, it can't read it. Well, it's got it now, but it didn't at first. Yep, short. I'd have to say the ANENG works better in that respect. How about high value resistors? 10 meg. Let's see. Can't read it. Ah, because I'm in continuity mode. Be fair on it. Okay. High resistance range. 20 meg. Reads about the same as the other one, 11.2. Now, to be fair, let's choose resistance range rather than continuity and try these low value ones again. Now it reads it, 0.1. Yeah, now it can read them. The ANENG actually did it on both ranges, but as long as you know that, that's fine. It's fine. This doesn't have a capacitance range, so we can't measure that. It doesn't have that facility. Screen backlight's okay. It has a hold, which the other meter had. I didn't test it, but it has that range. I've definitely got something wandering around on my desk here, guys. This happens when the summer comes along here. Don't worry about it, I don't. Voltage range, let's try that one. Well, we have 7.7 volts. That's what it says. That's what we have. This seems to be a little bit more accurately compared to the power supply, but there's no real way to say how accurate this is anyway. Let's see if we go down the range. Do we get an extra decimal point? Yeah, we do. That's nice. So up to 20 volts, we get an extra decimal point. That's what we want. I couldn't do this with the other multimeter because it was auto ranging. It wouldn't actually give me the option to do this. It was giving me 2 decimal points anyway. Let's go down again. So 2 volt range. Yeah, that's reading now down to microvolts on the final digit. I'm not sure if my power supply can give such low voltages. Let's see. According to this, like 10. Yeah. So this is giving us an extra point again. That's quite handy. Let's try the current range now, because this does have the low current range as well, which is what I often do use, and obviously the non-contact voltage as well. But while we're here, let's check the current. So I'm on the 10 amp range. We'll just put the leads where they need to go. Okay, and let's see what current we get. 0.45 of an amp. That's pretty much what that says. Let's give it a bit more voltage. Okay, 5 amps. That's about as much as I can get down with these leads again. Reading it fine. But this meter also has a microamps range, and this is something the other one didn't have. So let's try that. My main use for this is to test the current draw on a CMOS battery. This will give us a good indication on the condition of the chipset. Very useful on motherboards that will not boot up. So you can't say exactly what the current's going to be unless you've got another one of the same motherboards, but you can say it should be somewhere between about 1.5 microamps and below 10, basically. So somewhere in that region. Let's have a look at this one. So we hold the red probe on the battery, we put the black probe on the clip, and we push it back. And that's actually not reading anything. Okay, it's reading 0. So it's not sensitive enough to actually read the current on this one. I do have it in the correct place, microamps and common. Everything looks to be set perfectly fine on the meter to me. Let's try the other ANENG that I have. This is my ANENG AN8008. This is the one I normally use for microamp readings because it's more sensitive than the Fluke. It's probably the main reason I use this meter, the main thing I want to use it for. So we'll do the same thing. Red lead on the battery, we'll push this back. 1.9 microamps. That's exactly what you would expect from this sort of board, and this meter read it with no problem. Let's try the non-contact voltage. Oh, interesting. So I'll just bring this. Oh, okay. This gives you kind of like a graduated display. That's showing you, yeah, it's clearly showing you where the live side is. Okay, that worked well. So let's have a sum up. What do I think of these two meters then? This one, the non-contact voltage testing, definitely worked better. It gives you like a graduated display. It's also more sensitive. I think you could actually use this to track wires in a wall, to be quite honest. It worked from further away. So that I think worked better than this one, although they both do it. This one, it has the capacitance range. This one doesn't have. Diode test, both the same. Continuity test, both the same, and both seem to work pretty much as well as each other in that sense. If this one had a properly functioning, for my use, microamp range, then I think this one could possibly have won out, but neither of them can do it. This does have microamps, but it's not sensitive enough for what I mainly use that for. This one will not read below 20 milliamps, which is pretty useless to me for what I would normally use that for. So I wouldn't say that either of these meters have all the functions I really require from one meter. But if I was going to buy one, I will say now that at half the price, this one I think is the better meter. Yeah, I think it's actually the better meter at half the price than this one. So that's my view, and it was the microamp range that completely swung it for me in the end. If you're really on a very tight budget, guys, get yourself one of these. I don't think you'll be very disappointed with it. if some of you guys can recommend any other meter which is below €10 and not for a little bit more because you can. Yeah, of course you can for a little bit more. But let's be fair, if anybody else can recommend something below €10 that you think is better than this one, then let me know and I'll go and buy one myself and we'll try it. Yeah, keep these here, we can run them side by side. This one for €20, I'm sure you can do much better. Quite probably one of the other better ANENGs actually. Okay, so I hope you enjoyed that. I know you guys are going to be discussing this. I know there's going to be those down there, yeah. So let me know what you think, and I'll see you all soon on another Learn Electronics Repair video. Ciao for now, guys.